Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over how to balance nuclear equations, and I'll show you some practice problems. So let's get into this. So let's begin. So when it comes to balancing nuclear equations, they're pretty much just like balancing regular equations. What you need to do is make sure that both sides are equal. In this case, you're making sure that the mass numbers on top, the total amount of mass number on top on both sides is equal, and the bottom atomic numbers, the total is equal on both sides. So just like you're in a regular balancing equation, you're trying to balance the total amount of atoms on both sides, the both kinds. So you should have the same number and kind of atoms on both sides of your equation. In this case, you're looking at making sure that the total for the atomic number on the bottom is the same on both sides, and the total of the mass number, the top mass number, is the same on both sides. So let's get in this. So number one, we're given Pu has a mass number 239 and an atomic number of 94. So that's the only one on this side. So that means that everything on this side should be total, should be the same number. So that means that since this is the total 293 on this side, that means that both of these particles should total 239. So that means that I have a 4 here. So 4 plus some number should give me 239. Well, what is that number? I just subtract 4 from 239 and I get my number. So 4 minus or 239 minus 4 gives me 235. So I just put 235. Okay. And I do the same thing for the bottom number. So the atomic number of this element is 94. So that means that the atomic numbers for these two particles must be 94. So what is the number? I take the 2 here, subtract that from 94, and I get 92. So the bottom number is 92. And then all I need to do is look up 92, because remember, the atomic number tells you the number of protons, and the number of protons tells you the element. So you look up 92 and you get uranium. So I put a U there. And that's it for number one. Let's go to number two. Same thing. So the total on this side should equal the total on this side. So I start with the top number. I have a 40 here. So the total on this side is 40 for the mass number. And I have 40 plus something else. So I have 40 and some number up here. Well, what times or what plus 40 is going to give me 40? Well, it's the same number. So if I subtract 40 from 40, I get 0. So that means that whatever this particle is, it's got a mass number of 0. Next, I do the same thing on the bottom. So here I have 19. That's 19 total on this side. So I should have 19 total on this side. So I have 20. So 20 plus what is going to give me 19? Well, again, all I do is I subtract 20 from over here. So that's going to give me the total on this side. So here I have the total is 19. 19 minus 20 is a negative 1. So I got a negative 1 down here. Well, what particle has 0 mass? Oops. Sorry about that. So then the question is, what particle has 0 mass and a negative 1 for, say, charge, for example? That would be your beta particle. So what is a beta particle? It's an electron, basically. So we could either do E for the electron, or we could use the Greek symbol beta. So we could have 0, -1, and just have our beta symbol maybe draw that out a little bit more. So the beta particle. So either one of these symbols would work. Okay, what about number 3? Same thing. The total on this side for the mass number is 241. So that means that the total on this side should be 241. Well, here I have 273. So what plus 273 is going to give me 241? Well, subtract 237 from 241 and I get 4. So the mass number for that particle must be 4. And then I do the same thing with 95 and 93. So the atomic numbers here should add up to 95. Well, what is this number here? I take 93, subtract that from 95, I get 2. So that means that this must be a 2 for the atomic number. So since that's the atomic number, I have to look that up on the periodic table. When you look that up, it's helium. So this is an alpha particle. So we could write it like that, or we could use the Greek symbol alpha. So we would write that like so. So that is the particle, alpha particle. So this is an alpha decay. This is a beta decay. Okay, and this is an alpha decay, but they gave us the alpha. We didn't have to guess that one. We have to figure that one out. Okay, number 4, finally. So here we have rubidium as 85 and 85 for mass number, 37 for the atomic number. Here we're bombarding it with a neutron. So this is neutron bombardment. And so this is a symbol for a neutron. It has a mass number of 1 and 0 for the atomic number because it's not a proton, 0 protons. Also, it has zero charge. So that's another way you can remember that as well. Okay, so whatever this particle is, it's got to be the total of this side here. So what's the total on this side? So 85 plus 1 is 86. So this particle should have a mass number of 86 because they got to equal each other. And the same thing, I have 37 and 0, so that's the total of 37. So this particle should have a total of 37 for the atomic number. So since I know the atomic number, I can look that up on the periodic table. So I look it up. What's number 37? It's rubidium again. It's right here. Duh. Okay, so I have rubidium. So notice that it's a heavier isotope of rubidium since I added a neutron to it. Okay, next we have number 5, last one, NP again. So we had, no, never mind. I thought we had NP up here, but we don't. So here we have NP. NP has a mass number of 238 and an atomic number of 93. And then we're going to add to it 2 electrons, or so this would be electron capture in this example. So this is going to capture 2 electrons. We're adding that to this element here. And so we need to figure out what this element here, given that we have an alpha particle here. Okay, so again, both sides have to be equal. So on this side, since it's very important, if you have a coefficient here in front of your particle, then that means that you're going to have to multiply both the top and the bottom by that number. So since I have 2 electrons here, that means that I'm going to have to add 2 zeros to the top, and I'm going to have 2 negative ones on the bottom. So let's do the top. So the top here is 238 plus 2 zeros. That's going to give us 238. So that means that this side has to equal 238. Well, I have a 4 here. So what plus 4 gives me 238? So I'm going to subtract 4 from 238, and that gives me my number. So 234. So 234 plus 4 gives me 238. So that's the mass number of our missing particle. Now we have 93. So 93 here, we have the atomic number on the bottom, 93, and we have two negative ones. So 93 plus negative 2 is going to be a 91. Okay? So 91 total on this side. So that means that the total of this side should be 91. Well, I have a 2 here. 2 plus what gives me 91? Well, I subtract 2 from 91, I get 89. Now that I have the atomic number, I can look that up on the periodic table. I take a gander. Number 89. Where are you? I'm actinium. So AC. So the element is AC. And that, ladies and gentlemen, is how you balance nuclear equations, and also how you would determine what the missing particle is if you ever had to do that. I hope you enjoyed this video. I hope this was a learning experience. I hope you learned something from it. If you did, then please like and share my videos. Please hit that like button over there, and also subscribe to my channel. Make sure you hit that notification bell, and when you do, click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Make sure that you ask me a question. Let me know what you think. Also, if there's a video you want me to do, then let me know what that is. I would love to do it for you. Thanks for joining me, and have a great day.